Who are you doing?
Huh?
Who are you
Oh,
doing?
Rockefeller. Rockefeller.
Who are you doing?
J. Cole.
J. Cole.
Good morning. I said J. Cole. I said J. Cole.
You did say J. Cole?
I should have dialed out.
You did say J. Cole?
Shut your mouth.
I hope you got that. Oh, he didn't record.
It's
Oh, he did
okay.
record. I hope you got that on record.
I think he did. Big I don't mind, right?
Oh, you need that? Do you need it? I think you need it more than me. Because you can have it.
Man, what is this? He got this. Still got this in stool.
Wait, so you need
Hey, Kobe over here. Yo, then Jerry over here. Jared.
Guys, there's two different reviews. This one right here is a review of everything. It's new. I did it this morning. The other one was already up there, 1.3 and 1.4. Be careful walking in the back around that All right, guys. Imagine you're not going to find your thing right now. I'm going to get you one hold this second. All right. Everybody needs to make sure you've got on your desk what it says back there. I mean, up there on the front. It's been a great day so far. All right, I'll get on this side so you see. All right. And then you can talk and everything else. Now, all right, it looks like what's happening. You see everybody, it looks like just about every desk is full except for one. All right, now, I'll shake that, that's probably a card that got mixed in or whatever, and maybe they'll show up in a minute. Let me explain what's happening. It's been an excellent day. It's going to be excellent. I'm looking forward to seeing how well you do on this test. Now, what we're doing right now, I'm videoing from the back today because I'm videoing every class on the questions that I'm answering. Now, if you're sitting where your back is to me, it's okay to angle your desk a little bit if you need to. It's okay to turn it. You don't have to until you need a question. But I'm going to be working questions to help you do this. Now, I will tell you right now, there are good questions on everything I've given out. Some of you might say, man, he's been handing out paper after paper after paper. Here's the deal. I did this one that put everything on it this morning because I've got some classes where people have done everything. I need to make sure they see it. This has a good look at everything. Okay? Now, this one right here is focused on it similar. As a matter of fact, those may both be the same. This one was, all right, this was the 1.3 and 1.4. Now, it really has everything on it except the 1.3 and 1.4. Even it has some transformations, but it does not have anything about solving a system with same value problems. All right, now, I have posted online all these things I've given you. I have posted online how to work most of it. Now, I've already posted on Google Classroom first period answering questions and second period answering questions. I'm gonna post yours a little later, but I wanted to go ahead and have that on it. For some reason, I don't get them posted. I've already shown working problems. Now, I worked in both classes. The main questions we started with were, how do I create equations? How do I create equations using those three things? That was the major question. So that's been on both videos. In second period, they actually asked about the back of this review where it says solving using same value method or substitution. There's three of them like that. There's good word problems. So we did more of the linear equation word problem on the back. We did the one down here. We even did the pizza one. Second period probably has more problems worked than first period. Now, I'm gonna check roll and then I'm gonna be available. I would hope that you would work this review right here. Please do not try to grab all of these in these problems. I just gave you some like it. I have graph paper that's over here. If you wanted to draw some graphs and do a couple of those, but the biggest thing is knowing the transformation. So you have those right there. I would not sit here and try to work all these problems now. I might look at them and say, how did they transform the parent function? What is the family of function? That's going to be asked. All right. So you look right there. Let me check roll. And if you come up, I would take maybe one problem from each section. And then if I had questions, I would ask, and then I would go back and do another one from each section. But I promise you, you're going to have to tell me transformations. You're going to have to create equations, and well, something about the slope. But interpret the slope, interpret the relationship, and you're going to have to solve problems involving equal value. Now, I'll be with you. So I love the attendance in this class. You guys are always here. That's outstanding. All right, I've got other classes that I'm missing half the people every time. But it does you no good if you don't work it. You guys can go ahead and pass your cards toward the front.
Do you have one?
Guys, you don't have a card, I've got this up here. And Mark, you got some, I gotta straighten that out.
No, I'm doing it. How did I get this?
Jaden Morgan, are you in here? You have a card on your desk? You have a card, you had a card? All
I don't know. It's not what I was studying, but it's not.
Guys, I wouldn't waste this time. We've got about 40-something minutes. I would work one problem at a time. Tomorrow, you've got a test. That test you will finish during class, and there will be no retaking this test. This test is already going to be a retake of a mid-chapter test, a retake of a quiz, and it just adds a few problems about solving systems. There won't be any asking, how can I bring my grade up? There won't be any asking, this chapter one will be doing. You have a chance to ask, you have a chance to look at it. Tim, I'll take it off your ear because I can't see. Take that down, I can't see if you got a headphone in or not. All right. Here you go. Get these out of the oven, please. Oh, y'all are good. Excellent.
Are these two different? Which one is your best? I need the one because the only thing I'm not doing is see last So we just
Basically, right when you read, right after you got the and then right before you
Yeah.
so 3, 4, 5, 6 is 3, 4, 5.
I'm ready to answer any questions. I'm just filling out something real quick, ask if I need something work.
I think it might want to be like what is, what that, when what's
Yeah, graphic papers on
No,
there.
we didn't know anything. No.
To the right. To the right one. You only got 2 lines.
Not me. I can understand.
You know what? I don't know, whatever y'all come up with.
Oh, okay.
You told her it's negative, but just telling her it's negative, you need to know why it's negative.
This is still just what has happened here. Because if nothing ever happened, this would still say f of x equals x as like, I mean, as a value. But there's
Yes.
also being added by.
I got it.
Which sheet you on? All right, that one right there, all right, what number? Because this way I can help whoever's watching, if somebody watches this video. Number 9,
Well, how
okay.
would it
The key to number 9 is this.
If it's shrunk, it would.
They want you to, in the directions, they want you to graph the function and its parent function, then describe the transformation. So you have g of x equals x plus 4. What family is that? Oh, it's linear. Well, if it's linear, then my parent function is y equals x. All right? So if I graph my parent function, it goes through 0, 0, 1, 1. And most of your parent functions go through the order. So that's where you're gonna be starting. As a matter of fact, all the ones I'm gonna require you to do go through the order. It's either linear or it would be quadratic, where it's over 1 up 1, or over 2 up 4. And in that case, it's a u of parabola. That would be y equals x squared.
Oh, okay.
That would be y equals x. I can also tell you y equals absolute value of x. These are the 3 parent functions we're gonna do, 0, 0, 1, 1. And by knowing the parent function, you can now transform. Now, what does this, because how does this transform the parent function y equals x? Goes up 4. So from the origin, I'm gonna go 1, 2, 3, 4, put a dot. All right, now, what would you do now? Well, draw out where? You move the origin up. Now, I can move this one, but here's the deal. If I'm not vertically stretched, then it's still gonna go over 1 and up 1 just like that one did. It's gonna be the same slope, the same, it wasn't vertically stretched. So once I move it, it really moves everything, but I don't have to worry about that. Once I move this origin, I just go over 1 and up 1. If it would have been a vertical stretch, I would over 1 and whatever it says. So anybody that might be watching this video, this is number 9 on the graphing the parent function and then graphing the transformation function, and that would be the g of x. And that right there on the test, you'll have to name that. That right there would be up 4 and it would be linear. Because on the test, you're gonna have to tell me the family and you're gonna have to tell me how it transforms.
Yes.
Do what? Like,
Okay, so.
that's what I'm talking
17.
F of x equals.
Oh, well, now, this is something that I didn't give you, but I wanted it on there because when it just has a number, it's just a constant. It never changes. So what happens on that is,
Not slow,
the
right?
parent function actually is a slope of 0. Because it's 0x, so your slope is 0. Now, the parent function for a constant would be this. It would be, if this is my x-axis and this is my y-axis, y equals 1 is my parent function, or f of x equals 1. Anything that just has a number, like f of x equals 3, I just go up 1, 2, 3, and 1, 2, 3, and it's just a line. It's saying every point, a line where every point equals that number. So if, I'm not gonna test you on this one, but I do want y'all to see it, that anytime you just have a y equals, a number, that is a horizontal line. It's gonna say, because Y means up or down. So if you say Y1, then you want a line that is up 1. Every single point on this line, your Y is 1. Every single point on that would be,
So you see,
all righty. Anna Pond, you are checking out. So far today, if anybody's back there for watching the video, they have asked about the constant function, which probably ain't gonna be on there, but I need to talk about horizontal lines. Anytime it's just a Y or a constant number, it's called a constant function. All right, we've also talked about grabbing a parent function.
But that's the thing, this is not what we're doing. I understand this gonna be on the test.
On this one, just gonna
What, the formula to, you're talking about a formula to write an equation? To solve one or something, I don't understand what you're saying.
Just stretch my five.
All right, you wanna, what are you given to write the equation?
Nothing else.
I mean, what, the key is, are you writing a linear equation? But what is the, all right, so right, do you have a lot of kids already? Okay, now, so you've got to, what must you have to write any linear equation? Okay. So you've had your slope, what'd you get your slope to be? Negative 12 over 5, okay? So you got negative 12 over 5. All right, now, what else must I have to write an equation? A point. All right, so give me a point.
Okay, I get
60, 63, 6 and 3,
I
okay?
get this. I
So
get
if my slope is a negative 12 over
over
5, and if my point is 6'3", then am I gonna be using slope-intercept form, y equals
No, I don't.
mx plus b?
I
Or am I gonna be using point slope y minus y sub 1 equals m times?
Yeah, that's what I was wondering, that's what I'm.
You see how this is a V? This is a V, it is absolute value.
How do you know?
It's a V.
No problem.
Value don't go there.
You'll also have to interpret that if that's a word problem with directions, you'll have to tell me what's going down and that type of thing.
Oh, I know what a linear looks like. It's just mine.
Just remember, V is always an absolute value are gonna give you.
So what is all this right here?
We're graphing.
All this? No, you.
T-Bone, raise up, please, set straight up. There you go, do your
I
work.
don't want to get the graph.
Remy, take a pencil and just try to do something. Let's go work the problem. If anything, focus on, like T-Bone, that first one up there at the top. What number is it, 3? Does it start at 3? T-Bone, number 3. Can you tell me what family of functions that is? Absolute value, excellent. Because I'm showing you how quick you can get check marks on this test. Next thing, can you tell me how that one, T-Bone, can you tell me how the number 3, that equation they gave you, can you tell me how it transforms the parent function? Looking at the one they wrote down, the one they graphed, they wrote the big function. Can you tell me something about it that describes how it transformed the parent function? Well, the negative value, was that inside the parentheses, inside the absolute value or outside?
Oh, outside too, that's outside.
What's outside?
Negative
All right, so what does that tell me it did?
8. Go down 8.
Down 8, so right there, it goes down 8. What I'm telling you is I'm showing you, for somebody that may not have a clue what's going on, I'm showing you how quick you can get points on the test. All right, now what else is it telling you in there?
Go left 2.
So left, so inside there you have a plus something?
Yes, sir.
All right, so and it was, you said left how many?
Left 2, that's the opposite.
Excellent. Left 2, so I know
You already know.
going into it, that's three things. I can put that on there. Now, the last one would be the one separating you from 100% here, or what's that other two do to it? Is there a two in front of it?
Yes, sir, it'll make that go. Right,
I didn't know he was right there.
I mean, vertical stretch.
That's it.
So what is
That's it. That is a vertical stretch by a factor of 2. That's 100% on that problem. That was a transformation problem where he just told me on number 3, they wrote that equation and said y, I don't know if it was y, they meant for y, I don't know. Y equals, I think it said 2 absolute value x. He said it was plus 2 there, and then he said it was minus 8. If that was the proper thing, then he just got all 4 parts. Absolute value function, it's a B. It moved it 8 down, 2 to the left, all right, and a vertical stretch by 2.
Yeah.
That's how fast some of the problems are gonna be. That's how fast this first part of the section up here that comes from that quizzes. That quizzes is available for when I'm making the test. I'm gonna look at those problems, but that's a perfect example because you're gonna be writing it on the test. There will be no multiple choice. There will be no, there might be a word bank, but there won't be any multiple choice or any electronics being used other than a calculator. Yes. Which one?
One on the,
This one? Beautiful. Okay. So what did you write as your equation? Y minus 3. There you go. That's it. You're done. That's the equation. Yep.
Oh, we don't gotta solve it?
bro, how you forget what we did
How
last?
you gonna solve it? To solve something means you're finding the value of it. This is an equation that compares an X to Y. Now, what you're asking is, do we need to transform it into another form? Do we need to simplify it? If the problem says write the equation, you've just done it. Now, if it said put it in slope-intercept form, then I would just do this. I'd go y minus 3 equals negative 12 fifths x, and that'd be a positive. I'd let my calculator do that for me, but that's like, 72 over 5. I would definitely let my calculator simplify that, and then I would do this. So tell me what 72 over 5 plus 3 is. 72 over 5 is a fraction. No, I put fractions in calculator. What? Oh, no. The only way that would be is if this was over 5. No. What? 97 fifths. You did that on calculator? And I'll tell you why it's like that. Now, change that to a decimal. Do you know where the S to D key is? 19.4. See, I like that one better. Y equals negative 12 over 5x plus, you said 19.4. This tells me the line of sight, if you look at your line, it should look like it touches up there around 19 or 20. It should look like it touches up there around 19 or 20. If you've got a line, if we use the right stuff and have the slope correct, it should look like it touches up around 19 or 20. All right? Now, see, because 3 is actually 15 over 5. So if you added that, that would be an 87, let's see, that would be an 87 over 5. Check your 72 over 5 plus, oh, never mind, yeah, no, check your, check 72 over 5 and then add 3. It seems to me like it would be 87 over 5. And then you would add, then you could convert that, but just check the math. 87 over 5, yeah. All right, boom. So that's what we're doing. I don't see that being that ugly. What's the question? I don't know, they told me that. I don't know what slope is. Now, what points did they use to get the slope? Now, all right, y'all got negative what? Negative 3 is your slope. Okay, well, let's analyze. On that problem, does it say, describe the slope or, something about the slope? Did it say, what's the word I'm looking for?
Only thing it says.
Oh, that's all it said. Okay, good. Well, let's look, what is 12 divided by 5?
You saying when I don't know, 2.4.
So they got negative 2.4 for their slope, and y'all got negative 3. We're fairly close. If you're having to draw the line, I'm okay with that. And I'm okay with you, as long as you're not rounding, I'm okay with using those decimals as a slope. They're easier to substitute in. So see, like right here, this would be y minus 3 equals negative 2.4 times x minus 6. You guys had a negative 3. So yours would have been y minus whatever equals negative 3 times x minus whatever, depending on what your point was. That's it. And I would grade both of them. Now, I'm gonna tell you right now, I'm probably going to give you one that already has the line there, so that everybody's line should match.
So if it's empty.
I'm gonna try to do that, because I really don't want to hunt through everybody's slope and do all that. I'm gonna try to identify one that's got a couple points on it, to see who can find the slope, put it in there, and then interpret the slope. That's what we're
Anything
looking
in
for,
front of it,
interpret.
it's negative.
You can do slope using any 2 points on the line, yes.
Can you do 14?
I hope so. 14,
It is.
what's it say?
It says F, it's the graphical one, it's f of x equals 4 plus x in absolute value.
4 plus absolute value of x.
Yes, sir.
Love it. Anybody watching, this is number 14, and it's on the section that says graph the parent function and graph the function. And one thing, and then maybe tell the translation. The first thing I would want everybody to do is tell me, what type of family is that? Absolute value. So everybody here, you're gonna get some credit for telling me absolute value. I'll probably write those names at the top of the test. I wanna make the test as user-friendly as possible. Now, the next thing is that 4 inside with the x or outside?
Outside.
Is it multiplying or adding?
Adding.
So what is it doing to it? This is going up 4.
Okay.
Up 4. But so if you graph this, you gotta love the b's, because they're just 1 over 1 up 1. That would be the parent function. That would be y equals absolute value of x. This one says up 4, 1, 2, 3, 4. But I still go over 1 and up 1, over 1 and up 1. It wasn't vertically stretched at all, so that would be y equals 4 plus absolute value of x.
So it doesn't matter like where it says on.
Nope, it doesn't, all it's adding to it, it does not matter.
Can you do number 19? You gotta do
19, yes. 19, excellent. Now, anybody watch this video, this is one nobody's asked about in the other class. 19 says f of x equals 1/3 x. Could possibly be one like this. I can't see me crushing y'all with a bunch of horizontal, but this is on the outside. First of all, what family? Linear. This is linear, which means my parent function would have been 0, 0, over 1, up 1. That's the parent function of y equals x. How has this transformed that?
shrunk by 1 over.
That's right. Would it be a vertical shrink or a horizontal shrink? Vertical, it's on the outside. Now, so if you were naming this, this would be a vertical shrink by 1/3. Anytime you multiply by an A on the outside. Now let me show you. A lot of times, we don't know what that means for graphing. A vertical shrink means my movement that would have went up is going to be multiplied by 1/3. So, since this doesn't move at all, it still goes through 0, 0. But then it goes over 1 and up 1/3. Instead of going over 1 and up 1, it goes over 1 and up 1/3. So this one right here, that would be the graph of f of x equals 1/3 x. It's saying we're going up a third of the way the other one did. Instead of over 1 and up 1, it goes over 1 up a third. Instead of over 2 and up 2, it goes over 2 and up 2/3. So it slows down the height. It makes it flatter. A vertical shrink makes it flatter. Like if I shrunk this one, if I said y equals 1/3 times the absolute value of x, I would go over 1 and up a third, and it would be a wider, that would be the graph that would do. If it was a parabola, it would just make the parabola open wider, like you sit on it. So, anybody that might be watching third periods class, we're doing more with transformation. We hadn't done that in the rest of the classes yet. 22 on that same part. And again, y'all don't have to do every one of these now. Hey, look, there's not going. It ain't like there's going to be 20 problems on this. You're going to have like 1 or 2 transformation problems. Don't let this bog you down. But I do like you asking me what you can't do. So let's say you said 22. All right, let's look at 22. Not in here. All right, but yeah, you can try it out there. All right, 22.
Oh, he said,
H of x equals 3/4 x. All right, this one, I think that says 3/4. Was it 22? Okay. Again, this one is just like the one we did a while ago, because the 3/4 is like 0.75. It is right. I mean, which problem are you talking about? 22. Oh, I'm sorry, I did. Okay, so 1/3 x squared. All right, now. All right. So was it like h of x or whatever? But it's 1/3 x squared. Still the same thing. The 1/3 means I'm smaller, so here's what I do. The parent function, first of all, is quadratic, which would have been 0, 0, over 1 up 1, over 2 up 4.
So it's just.
I could go over 3 up 9, but I'm not going to do it. That would be the parent function. That's y equals x squared. The 1/3 says, this is a vertical shrink. Vertical is your up and down movement. So I'm going to multiply that by 1/3. So I'm going to go over 1, and instead of going up 1, I'm going to go up a third. So what it does is it makes it wider. This would be the graph of h of x equals 1/3 x squared.
What are you doing?
All right, it made it flatter. The vertical movement went up and made it flatter right there. What? Oh, I love it. So you're down on the bottom. All right, good. We've been on a lot of those transformations. I'd rather move it. So you're down on number 2. Guys, this is the first, anybody on the video, this is the first person in my first 3 classes that asked about number 2 down there at the bottom that uses the table. Now, number 2 says the table shows the tuition cost for a private school between the years of 2010 and 2013. A says verify that the data shows a linear relationship, then write an equation for the line of fit. So now, if you're doing this one, I can't see me giving you one where you've got to actually put the points on there, but it could happen. So if I were doing this, this down here would be years after. What do you do? You have to send it to me. years after 2010.
Yeah,
You still don't understand.
And then this one over here would be tuition. $10. Now, I got to pick, first of all, the years after start off with like 0, 1, 2, 3, and 4. I had graph paper, but I'm just drawing a sketch while we're doing it now. Now, these numbers are pretty ugly, but I'm gonna check it. It goes from 36 to above 40. So what I'm gonna do is, I'm gonna do it this way, and I'm gonna go by thousands. I'm gonna go 36,000. I'm gonna go 37,000. I'm gonna go 38,000, 39,000, and 40,000. And another 40,000. These are in thousands of dollars.
Then I go home and I try to study them and then I
I promise you, I'm not gonna get one this ugly because these numbers, but I probably maybe have a graph for you, but here's what we do. To see if this is linear, I'm gonna go 0 and I'm gonna go 36,208. So about 200 over that, I'm just gonna put it there, make the dot, you know. The next one, I go 1 and 37,620. So 37,620 is gonna be a little bit above halfway. I'm just estimating. Then I'm going 2, 36,088, 2, 36. No, that's 39, I'm sorry. 2 and 39, oh, so it's right above 39. And then I'm gonna go 3 and 40 and 5 nut. So 40 and 5 nut, so I'm about right here. Well, to me, that's looking about linear. So here's what I would do. This would make it easy. I'm gonna use this point, and I'm gonna use that point right there. It's not a great line of fit. I could have used this one and this one, would be perfect. As a matter of fact, that's what I'm gonna do. Because if I did this one and this one, then I have one of them below it and one above it. Let's say I had that for you. The problem says, verify that the data shows a line. Well, that does. Then it says, then write an equation for the line. So right here, this, now that that's up here, this is one you would have on your test. It's graphed. I would tell you that this right here is 0,36208. All right, and this one right here is 2 and 39,088. I'm giving you those 2 points. Now it says write the equation of the line. So what would I have to find to write the equation? Boom. So I'm gonna go slope equals, and I would go 39,088 minus 36,208, and I would go 2 minus 0. The bottom number is gonna be 2. The top number, I'd have to use my calculator. 39,088, 36,208. 700. No, what is it? 2,800, what? Now, and then since that's even, I would divide 2 into it, and that gives me 1,440. That's my slope. Now that looks ugly, but that happens. This is, we're talking about thousands of dollars, and we're talking about tuition. Tuition does go up. I mean, everything's going up, all right? But tuition climbs just like everything else. So I believe the next thing says, interpret the slope and y-intercept. Well, the y-intercept, that point right there, 0,36,208, what that would be, I know in a second, I want to finish this one, especially for the video camera, but watch it. Since it says years after 2010, 0, that is cost in 2010, right there. That's what this would be. At the start, it was 2010. Everything past that, 2011, 2012, Now, what does the slope mean? Look, done your Y mean $1,000. So this would be, it would be 1440 increase per year. That's how much that'd be increased. But watch how easy it will be right between. You see how that's the intercept? This would be Y 1440X plus 36,208. Now, as you're putting things up, which is fine, you might want to look at number 2 that's down there at the bottom. I don't think I'm going to give you one where you had to actually plot the graph. But if I gave you one like this with those 2 points identified, listen up, or whoever back here, that's your y-intercept. We found our slope. If you know the y-intercept, it makes it easier, because that's your slope-intercept form. This would be relating cost, all right, the cost to years after 2010. All right, once you've got everything ready to go and sit down and look up here. Let's say this is problem number 1 on the test. Actually, it wouldn't be problem number 1. It would be problem number 1 in the middle of the test. And it might have this right here. And it might have a line right there, and it might say something like 5,80. And it might say something like 7,100. Now, I haven't given you a name, I haven't told you what it deals with, but first of all, if I said, write an equation, what would you find first? Oh, boom. What would go on the top? All right, what other? 100 minus 80, 7 minus 5, that would end up being 20 over 2, which is 10. So whatever you had right there, that would be, if this was dollars per item, what would this slope tell you?
Every item is $10.
Every item is increasing
By
by $10. It's increasing $10. So every time I buy another item, it's increasing by 10. So it's really $10 per item. It's $10 per item. That's $10 per item, that's what it is. Every one of them's $10. Because it's increasing, I mean, you're buying it, so it wasn't like it was 10 over 3 or 10 over 7, it's 10 over 1.
Well, that would check out.
Now, if you wrote your equation, what would it be?
Y
Y,
equals 10x.
you don't have the y-intercept.
Oh, Y minus 5.
Oh, I was saying
Not
bills
5.
line
Oh, I
up.
mean, 80.
80 equals
10
10 times,
X minus 5. 5?
that's it.
Yeah.
Could you have used the other point?
Yes.
Yes, you could have.
Wait, so if you did legal aid? No.
Yes, you can leave it like that. Now, you got 2 minutes. Now, what if I said, how much would it cost for 45 items?
What
If I said, what would the cost be for 45 items?
45 for the
What?
That's exactly right, because that's your next thing. So it would be 45 minus 5 would be 40, so it'd be 10 times 40, which is 400, and then you would add 80, and you would get Y equals 480. So it'd be $480, that's how you take it and solve it. Yes.
So
Oh, what you got?
if you had it in the slope intercept form, you could also plug in 45.
Yes, if you would have simplified it, you could do that. And it would be easier to work, but you would have had to do the work ahead of time to get it in that form. Slope intercept form is easier to work with if you know the intercept. Now, you guys might want to watch second period's video because it showed more of the ones that dealt with solving the problems that deal with, same value, the pizza problem. I think it says how many toppings is gonna make the large pizza the same, and you can work that. It's got the answer on that. Yes.
A lot of those, like, okay, I know how to figure it.
Oh, so you're talking probability or statistics? Dr. Morning Dave, appreciate you. Don't forget your items, I'll sell them.